Welcome guys to our last interview question, and this will be the last video on arrays and sequences. So now let's look at the string compression problem. So it says given a string in the form AA, BB, CC, DD, EE, compress it to A4, B4, C5, D2, E4. For this problem, you can falsely compress strings of single or double letters. For instance, it is okay for AAB to return A2, B1, even though this is technically more space. The function you create is to be case sensitive, so this means that a string that is A, B, small letter A, small letter B, A, and that will return A3, B1, small letter A1, and small letter B4. Okay, so now let's go to our paint thingy and actually come up with a solution there first in pen and paper, and then now go to our text editor. So I guess by now you guys saw, even from the last videos, before I start coding anything, first come up with a solution in pen and paper to actually then start coding, because this helps a lot in reducing errors, and it's best practice for you to actually come up with a problem in pen and paper to come up with a feasible algorithm design. Now that we're here in our paint thing here, so now let's see what we're actually dealing with here. So let's say we're given a string that we're given a string A and B. So we need an algorithm that will go through this entire string. Then after going through this entire string, we need a dictionary that will keep track of each and every occurrence, right? So the moment we see the letter A, we know that we initialize it first, because it will be the first time we see it, that we initialize it to being 1. The moment we see it again, we add another 1. So now this will be our A letters. And then now we're going further down the line. So now we see the letter B, and this is new to us. We then initialize it to being 1. And then we see it again. We then initialize this, not initialize, but then increment this by 1 again. And then this will be our occurrence number of times of this letters, which will be 2, and then 2. So thereafter, now that we have everything or every letter that has occurred within the dictionary, that we then loop through this dictionary to actually output the output that is needed, that is A2, B2, B2. So this should be basically our algorithm that we're having, right? So now let's go to our text editor to actually code this up, and then we'll be done with our string compression problem. Okay, so now that we're in our text editor, so now let's code what we talked about in the paint slide, and then see how this thing actually is done. So we can say define string compression, and then we take in our word, right? So here we can just make a test case that if the length of the word is equal to 0, then this is an empty word, which is return nothing. So thereafter doing that, we need a dictionary that will keep occurrence or keep count of each and every letter. So you can just say synmap, and then after that we need to iterate through each and every letter within the word. So say for letter in range length of the word. And what we want to do is we then say if the word letter not in synmap, what we want to do, we want to initialize this word to being 1. And this word to being equal to 1. And then else, if this is a word that we know that it's in the synmap, what we want to do is we want to increment in this word by 1. So now that we actually went through the entire word, now we want to go through the entire dictionary to now actually get our output. So we say for letter in synmap. So for letter in synmap, so what we want to do is we want to print out this. So we can say print. How can we do this? So we want to say the A2. So what we want to do, we can say print and then we'll just put an F literal. So we can say the letter, yeah, and then we give out the actual number now. So we can just do that like that, and then we get its corresponding number, and then that should give us our and then we put everything in one line, and then this should give us our output that we need. So let's test this thing out, and we say okay, so let's say our word is equal to a. So we have 5 A's, we're expecting A5, and then BB, EE, DD, and then we print string compression, and then we pass in the word. So here we're expecting A5, B2, E2, and D2. So let's run this and see what we're actually getting. We actually get that A5, B2, E2, and D2. So just ignore the none. So we're getting this none value because we're printing within our function and printing outside the function. And if we were to return, I would actually not get, or would not be able to use this syntax that I used within this curly bracket. So just ignore the none, but then the output that we're getting is A5, B2, E2. Now let's check if this thing is case sensitive, and it will give us what we want, and then we'll be done with this string compression. So let's just add A, B, and DE. So we're expecting to get A4, small letter A4, small letter B3, small letter D2, and small letter E2. And let's run this, and we actually get what we're wanting. A4, small letter B3, small letter D2, small letter, and E2, small letter. So this is basically the string compression algorithm that we needed to solve this. Now let's look at the time complexity of this algorithm. So here we looping through n number of words. So we know that we have that n, and we also looping through n number of times in the synmap. And then from what we've done previously on the other interview questions, you saw that the moment we add this to nth, we'll have 2n, but then the coefficient is insignificant to us, and then we'll have an order of n algorithm, right? So Guys, this is the end of arrays and sequences. Hoping to see you guys in the next chapter, that is recursion. I hope you guys enjoyed the arrays and sequences chapter, and I hope you guys learned a lot. See you guys in the next chapter. Goodbye.
Ready to let go. You decide if you're ever